Hi guys, it's I, Sir Bertosh of Handsometopia. And in this video, we're going to learn about how energy travels through the universe, sometimes as waves. If you have been watching these videos and completing the mastery badges that go along with them in order, then you are probably by now, one, an expert in energy, and two, very tired of me repeating some of the same things in each video. So we're going to do that again, just to make you happy, just to exhaust you a little bit more. So we have been talking about how energy is what? It is the ability to do work. Energy allows things to move and do work in the universe. And we've talked about how energy cannot be created and cannot be destroyed. It can only change forms and move around the universe. And we've talked about some ways that energy moves around the universe, such as mechanically, when one object bumps into another and the other object goes flying off, like in a Newton's cradle, or when you're playing billiards, pool, on a pool table, or when asteroids smack into each other. Another way that we talked about in another video that energy can move through the universe is in the form of light or heat or electricity or sound. Well, often when energy is moving, when it is out and about, and it's moving around the universe, one way that it travels very frequently, not always, but very frequently, is as waves. Because here's the dealio. Here is the dealio. When you put energy into a medium, and when I say medium, that's just a big fancy sciencey word that means stuff or a substance. So if I have a medium like water or jello or whatever, the ground, the earth, and I go plop and I place a whole bunch of energy right on in that medium in some random point. So imagine a big medium, an ocean, or a giant planet of jello, because that would be fun. And I pick any point in that medium and I plop a lot of energy right on that point. Well, what is going to happen? Is the energy going to stay there? It can, if it's potential energy. If it's in some sort of form, like it's a battery, and I just carefully set it down so it doesn't actually create, mechanical energy. But if I'm just like dropping a bunch of energy into a place, it's probably not going to stay there. It's going to, from that point, that central point where I put the energy, it's going to move outward in every direction. It's going to look like a bullseye, and it's going to form waves. Waves are going to ripple outward from a central point. And you are familiar with this phenomena, aren't you? Yes, you are, because you have seen it whenever you drop a rock into a lake or a pond or your bathtub. I don't know why you're putting rocks in your bathtub, you strange person. But if you are doing that for some unknown reason, but maybe you're dropping your bath toys into the bathtub, then it's going to create ripples from a central point moving outward. And so that's a key thing to understand. When you see waves, we sometimes think of them as straight lines because they look like they're straight lines, but actually they are circular and they are moving outward from a central point. Even the waves in the ocean are circular. It's just that the circles have gotten so big that they might span thousands of miles. So you're getting one side of that wave on the beach, on the coast where you are, and somebody else, thousands of miles away, might be getting the other side of that ripple where they are on their coast. As waves move from a central location, as they ripple outward and create this floppiness in the medium, what is moving? Is it the medium itself? Is it the water or the jello or the land? When I say moving, I don't mean up and down, because obviously the water and the jello and the whatever are moving up and down. When I say land, by the way, think earthquake. That's why I use land as an example, because waves move through land as well. But anyway, so I don't mean up and down. I mean forward, because if you look at a wave, you can see the wave. It's expanding outward. It's moving across the medium. But is it the water that's moving forward? The answer is no. It's the energy that's moving. The energy is moving through the medium. The water goes up and then down, but it stays the same place. The water molecules stay exactly where they were. Or if it's jello, the jello doesn't move forward, right? That's a little bit easier to imagine because we know the jello is not going to move forward because it's stuck there. Same with land. So when there's a wave, the energy moves forward through the medium, fancy sciencey word that means stuff, through the medium, causing the medium to go up and then back down. But the molecules, they don't move forward. It's just the energy. And we can measure. We can measurify. We can measure, but it's way more fun to say measure. We can measure how big waves are. Scientists often measure the waves, a wave, because they get important information about the wave by measurifying it. For example, with sound, we can determine the volume and the pitch based on the size of the wave. So there are two ways that we measure waves. Well, there's more than two, but there's two that we're going to talk about right now. One of those is called wavelength. What do you think wavelength refers to? This will totally shock you. It refers to the length of the wave. I know, right? Crazy. So the wavelength is the length of the wave, and we measure it from what we call the crest of the wave. Crest is the top of the wave. So we measure it from one crest to the next crest. Though, in all honesty, we could pick any part of the wave as long as we go to the same part of the next wave. So we could go from trough to trough. Trough is the bottom of the wave. Doesn't matter. But we tend to go from crest to crest with the wavelength. So we take out a ruler or whatever, some sort of device, some sort of measuring tool, and we measure. I mean, you can't really use a ruler with sound waves, right? We have to use other technology. But we measure the distance from one crest to the next, and that gives us the wavelength. And the other way to measure a wave is amplitude. Amplitude, you might call it the height, sort of the wave, except that we're not going from the trough to the crest, because that's not the height of the wave. The wave is its resting point is where we want to measure from. So we're going to start at the resting point. That's halfway between the crest and the trough. Because see what happens with a wave is that the wave goes up, right? So if this is like where it would normally be, if it was, well, now I'm covering my face, which is probably a good thing because, I'm so handsome. Anyway, or not, depending on who you ask. So if this is the normal resting place, then the wave is going to go up. I can't bend my hand that way. It's also going to go down. So this is the resting point. The wave goes up to create the crest, and it comes down to create the trough. So when we measure the height or the amplitude, we don't want to account for the trough because that's going down from the normal resting point. We want to measure just how much is the wave changing from its normal, if it were a calm day and there were no wind and nobody throwing rocks on the lake, the flat surface of the water. When you make it go up on one side, you're making it go down on the other. And if you measure that, you're going to get double the actual height of the wave from its normal resting place, okay? So we have wavelength, which is the length of the wave. We have amplitude, which is the height of the wave, but it's measured not from trough to crest. It's measured only from the resting point to the crest, although you could go from resting point to trough too, because that's the same measurement. And these give us important information about how big a wave is. Remember that waves move from a central point in a medium outward. The medium can be really anything. When I plop the energy down into that medium, and the waves are going to ripple outward in every direction, going up and down from a central resting point, creating troughs and crests, well, crests being up and troughs being down. Those ripples move outward. It's the energy that's moving. It's not the molecules in the medium. The molecules only go up and down, but the energy is what is moving forward. And we can measure the size of the waves in terms of wavelength by going from one crest to another, or one trough to another, and also the height of a wave, which we call amplitude. But we don't measure amplitude from trough to crest, because that would be double the actual height. We go from the resting point to the crest to get the height of the wave. Hi guys, thanks for watching my video. These rambling science videos where I go unscripted and just kind of barf up all the science knowledge out of my head are part of a series that go along with an online class that I teach, which you can sign up for if you go to handsomescienceteacher.com. I also have a whole bunch of free resources for homeschoolers. I have hundreds of articles on every topic that covers your entire science curriculum from 5th through 8th grade. I have online games and quizzes, all curated and written by this handsome guy, a science teacher with, well, three degrees, but 2 of them are in science. So it's targeted right to and directly to your science students. So sign up, subscribe to the channel, and I release lots of videos. Also, in addition to these ones, lots of little short videos that are like 2 minutes long that cover science topics. Those ones you don't get to see my handsome face, but they're still good videos, and they're much more targeted, and those ones are scripted, so you don't have to hear me like you are right now going blah blah blah. The end. Subscribe. Thank you. Goodbye.